Good morning. Today we're going to work on lesson 3.3. It's called Buying Stuff Without Money. I wonder how we can do that. So there's going to be a couple parts for this, so make sure that you watch all the parts for the lesson. There's 2 sections, and here we go. I'm going to share my screen. So quote for the day says, before borrowing money from a friend, it's best to decide which you need most. That is true. You know what? Borrowing money from a friend or family and loaning money to friends and family, it doesn't always work out well. So I try not to do that. A fixed installment loan, that's where we're starting, is a loan that is repaid in equal payments. Sometimes the buyer will buy part of the cost, pay for part of the cost at the time of purchase. This is known as a down payment. Here are some other key terms we're going to use to describe installment loans. The amount financed is the amount a borrower will pay interest on. So the amount financed is the price of the item, subtracting the down payment if you have an amount for that. Total installment price is the total amount of money the buyer will ultimately pay. And you calculate this by taking the sum of all the payments plus the down payment. The finance charge is the interest charged for borrowing the amount financed. And you calculate that by taking the total installment price and subtracting the price of the item. The difference will be the finance charge. These would be good to have on your note sheet for the final. So let's look at our initial problem here. It says, now let's take a look at the problem posed in the lesson's opening paragraph. Hopefully you read that about there's some advantages of borrowing money. And it says you're buying a car that costs $12,260. You have a down payment of $3,000 that you saved up. You're going to put down on the vehicle. And they told you that your payment's going to be $231.50 per month for 48 months. So all of that information is listed right here at the top of page 288. It says, what was the amount financed? Refer to the definitions on the previous page. So the amount financed here is the price of the item minus the down payment. So the price of the item was $12,260 minus the down PMT payment, and that was $3,000 you had saved up. So now you only have to take a loan out for $9,260. What's the total amount of all payments? So that would be the monthly payment times number of payments. And the monthly payment is $231.50 times the 48 payments. So that comes out to be $11,112. What's the total installment price? So that is the total payments plus the down payment, because you have to include you did spend money on that. So your total payments was $11,112 plus the $3,000 that you put down. So the total installment price was $14,112. Okay, so here's an amount that you borrowed from the bank to borrow from the bank. They told you that you were going to make this payment of $231.50 each month for 48 months. So you paid the bank back this much, even though this is all that you borrowed. It says find the finance charge, then describe what the amount really represents. And the finance charge is the total installment price minus the price of the item. So the total installment price is $14,112 minus the price of the item. And this is going to be the finance charge. And that comes up to $1,852. That's what you're paying for your finance charge. Okay. In some cases, it's a good idea to be able to calculate a monthly payment before making a purchase. Not only can this help you decide whether or not you can afford an item, it gives you a way to make sure you're not getting cheated when you're quoted a monthly payment. So how can you find a monthly payment for a loan? We're going to use this formula here, and it looks kind of complicated, but the more we use it, the more you practice with it, the better you'll feel about using this. Also, I encourage you to type it into Desmos and save it, and then you've got it there to use for future use. So let's go through this formula. M is for the monthly payment that you're calculating. P is the principal that you're borrowing. The money that you're borrowing, not the total cost of the item. So if you've calculated a down payment in there, this is only what you're borrowing. R is your annual interest rate. And then N is the number of payments that you're making. And make sure you've got a negative on that exponent. There's a reason for that. Okay. So let's look at number 5. It says, have you noticed that car makers never have sales? They're always events. Anyway, they want to make it sound special. Anyhow, for the Honda 2019 President's Day event, they offered a certified pre-owned CRV with a special APR rate of 2.9% for 60 months. If one particular vehicle has a selling price of $27,295 and a buyer trades in an older car for a down payment of $4,500, calculate the monthly payment for this loan. So to do that, we have to have P, R, and N. So let's just write P. So P is what we're borrowing. So that's going to be the selling price minus the down payment. And so we're borrowing $22,795. The rate is 2.9%, so 0.029, and N is the total number of payments, and they told us that, which is 60. If they give you the number of years, you have to multiply that by 12. So our formula is going to look like this: 22,795. And then in parentheses, 0.029 over 12, because you're making monthly payments. 1 minus parentheses 1 plus, and then the same fraction from up above, 0.029 over 12, and then an exponent of a negative 60. Excuse me. We're going to put this into Desmos. So I'm going to share my screen, and I am going to show you how I encourage you to just make one file that's just a monthly payment formula. So I'm going to put this in as an example so that I've got numbers in there. So 22,795, and then I'm just going to make a fraction, and then once you get the fraction going, then you can edit it. So I want to have a parentheses here with 0.029 divided by 12. And then on bottom, I have 1 minus, and then a parentheses, 1 plus, and then my fraction. And then my exponent is a negative 60. And I'm going to save this. Oh, I need to log in. That's why it's not. Not letting me save. So I'm going to save this, and I'm going to save it as monthly payment formula. Okay. And so then anytime I want to do it, then I can just go to this, and then I've got the setup all right there. That's what I would do. So this happens to be ours right here. So it looks like our monthly payment is $408.58. So let's go back to page 289. And as a reminder, number 5 here is the lesson check for lesson 3.3. And here's the answer. And you'll type in $408.58, and then make sure you're choosing the units of dollars, of course. So that's what our monthly payment is going to be. So number 6 at the top of page 291 says, if the loan was based on simple interest, the future value would be $22,795 times 1 plus the interest rate times 5 years. Calculate this amount, then divide by 60 to find the monthly payment. What do you think accounts for the fact that simple interest makes it higher? So we're going to type that in. I'm going to, and doesn't know, so I'm typing in a 795 and 1 plus 0.029 times 5. And it looks like with simple interest, we would have 26,100.275 divided by 60 for the monthly payment here. And the monthly payment using the simple interest would be 435.00. And they're asking, why do we think that this would maybe be higher? And my guess is that it's higher for the fact that the other formula for the monthly payment is taking into account that it's going down every month as we make that monthly payment. And so in simple interest, you're getting interest, the same amount you're paying every year. But the monthly payment is taking into account that as you make payments, you're owing less and less. So that's why. Okay. So let's go down to the middle of page 291 here. It says many lenders add upfront fees to a loan as over the life of the loan. This has the effect of making the actual interest rate that a borrower pays higher than the quoted rate. Because this can get confusing, lenders are required by law to disclose an annual percentage rate or APR that reflects the true interest charged. This allows consumers to compare loans with different terms. The mathematical procedures for computing APR are pretty complicated, so we're going to take advantage of built-in commands on the TI-84 graphing calculator for computing APR. This is described in the solved example. Now, we are not using the TI-84. We're using Desmos, okay? So don't worry about that. We're just going to use this rule of 78 here on page 293. So it says when you take out a loan for a certain length of time with fixed payments, the usual path is to continue paying for the entire time until you don't owe anymore. But if you have the money to pay off the loan early, you can save money because you end up having to pay the total amount of interest because you don't end up, you're going to pay it off early. But how much do you save? Is it worthwhile to pay a big chunk of money to save some of the finance charge? Let's take a look. The amount of the finance charge that you save when paying off a loan early is called unearned interest. And it's because the bank has unearned it. They haven't earned it because you're paying that before they've earned that money from you. There are a couple of methods that are used to calculate unearned interest. We're going to study one called the rule of 78. This is a formula that you can use to calculate it directly. So we're going to be trying to find U, the unearned interest. F is the finance charge. K is the number of remaining monthly payments, and N is the number of original payments. Okay, so when they say finance charge, they mean how much are you going to pay? If you pay all those payments, how much is that finance charge going to be? So let's look at our situation where we borrowed the $12,260 of the car, and we had this down payment of $3,000 from the beginning of the lesson. Use the rule of 78 to find out how much interest you'd save if you pay the loan off with 12 payments remaining. You'll need the finance charge you calculated back in question 4. So let's go back to question 4 and get that finance charge. And we found out that it was $1,852. Okay. So to find the unearned interest, we need to know F, which is the finance charge. So 1,852 times K. K is the number of remaining monthly payments. And it says 12. So K is 12 times K plus 1. So 12 plus 1 or 13. And then N is the original number of payments. And originally we were going to pay that in 48 payments. So we're going to do 48 times 48 plus 1. Let's go ahead to decimals here. And okay, so the decimals, we're going to type this 852. Okay, and then I've got, oops, 12, and I'm going to type it just like I have it written on my paper, but you could just do 12 and 13. And then on bottom, it's 48 times 48 plus 1. And again, you could just do 48 and 49 if you want. So it looks like the bank is not earning a full $122.84 from us. Wow. So I'm going to show you that on my paper. So the unearned interest is $122.84. So number 8 on page 294 says, in this situation, you would surely want to know how much it would cost to pay off the loan. The first step would be to find the total cost of all the remaining payments after the 36th payment. So do that. So there would have been 12 payments left. Number of payments remaining times the monthly payment. And the monthly payment we said was $231.50. And so we would need this to pay it off, right? Your answer to question 8 is what the payoff would be if you weren't getting credit for unearned interest, but you are. So subtracting the unearned interest you found will give you the payoff amount. So the payoff amount is total And I'm writing this in words so that you will write it in words. So you've got directions for yourself. So total remaining payments minus the unearned interest. And so that would be 2778 minus the 122.84. So their payoff amount should be, and you should be practice typing this in as well, $2,655.16. And then we're just going to discuss pros and cons of paying off the loan early. So pros would be you no longer have the monthly payment, right? That's definitely a pro. A con would be you have to come up with that amount, right? That payoff amount. You have to come up with the payoff amount. Now, if you were blessed with a bonus at work, or grandma, grandpa, or mom and dad gave you a chunk of money, then that would be a blessing to use that money to pay it off, because you're saving $122 and in interest that you're not going to pay the bank, that you would be paying over the next 12 months. So definitely something to consider. But if you don't have the money to upfront that $2,655.16, then you're going to have to just keep making your monthly payments and know that the $122.84 that you would pay in interest is worth it, because you are getting the car paid off. It's just sometimes slow and steady wins the race, is the way I see it. So catch us back for the second part of lesson 3.3.